What is machine learning? What are some of the examples you might have come across, say, in your real-life applications or use cases? Suppose you're speaking on your mobile phone and you mention to call one of your contact names. You notice that some mobile phones can recognize what is being spoken and can call the right person. This is an example of what is known as speech recognition, and machine learning is used here to support speech recognition. Another example is of object recognition, in which, given an image of an object, such as a car or an aeroplane, the system automatically recognizes the object correctly using machine learning. Let us now discuss an example from healthcare domain that uses machine learning. Suppose you only have a limited number of hospital beds, and you would like to predict which patient is more likely to need access to an emergency ward. So here, you can build a predictive model using machine learning methods and determine who should receive emergency care based on the physiological data and medical history. Let us now consider an example from the banking sector. Here you may want to find out which customers are likely to default a loan. For this, you will require a variety of attributes from the customer: demographics, gender, credit rating, any other existing loan, job security, bank balance, among other things, are factors to be considered. You may want to predict if a particular customer will default a loan or not based on these factors. This is an example of how you can use machine learning to predict if someone will default a loan or not. These are some of the examples where machine learning is used. For different applications, you require different types of data, and then you build machine learning models to make predictions according to the relevant problem statements. Let us now talk about three different types of machine learning algorithms: regression, classification, and clustering. What are some examples of regression, classification, and clustering? Let's start with regression. Let's consider a scenario where we are trying to predict a student's score. For example, their scores in a predictive analytics course based on their Class 10 math scores. Given the Class 10 math scores, we want to predict their scores in the predictive analytics course. Let's imagine that you have previous cohort batches data from which you would like to develop a machine learning model and use it to estimate the scores of a predictive analytics course. So, we have the math scores and the corresponding predictive analytics scores for different students from the previous batch. What we want to do is, for the new incoming batch, given their math scores, we want to predict their scores in the predictive analytics course. The score might range from 0 to 100, and it will be a continuous numeric value. And what we want to do is to predict that value for different students. This is what the regression problem is all about: predicting continuous numerical values. What about classification? What can be a good example for classification? Let's look at the classic example of spam versus ham classification. That is, given an incoming email, we need to classify whether it is spam or not spam, that is ham. Unlike a regression problem, the output here will not be a continuous numerical value, but a class from a predefined set of classes. In our case, an incoming email can either be spam or ham, only one of these predefined discrete classes. So how do you build a model to predict whether the email is spam or ham? For this, you would require a lot of data, that is, historical emails labeled as spam or ham. We will then use machine learning to develop a model such that, given a new unseen email, we can correctly predict whether it is spam or ham. Now, we have an idea about regression and classification. Let us discuss about clustering. A classic example of clustering is market segmentation. Suppose you have a large amount of customer data and you would like to offer different discounts to different customer segments. In this case, you can group your customers into different categories based on their characteristics and then decide on different discounts for each category or segment of customers. This type of problem is referred to as clustering. What is the difference between classification and clustering? Both of them are, in some sense, producing categorical variables. The main difference is that we do not have the concept of labeled data in clustering. In the case of classification, we had the labels spam or ham in the training data, and we used this training data to train a model which eventually helped classify unseen emails as either spam or ham. Clustering, on the other hand, does not require labeled data. In our example, we start with a large amount of unlabeled customer data, and then the model clusters the customers into different groups based on similar characteristics. We then go ahead and discover or interpret what the clusters are on the basis of what characteristics the model clustered the customers into. We can possibly figure out that in one cluster, the customers are more price sensitive as compared to another cluster or clusters. It may also be possible that one cluster has teenagers predominantly, and another cluster has middle-aged people, and so on. Thus, we do not start with any preconceived notions of what the cluster should be. Instead, we just learn and discover as we go along. Another example of clustering is related to news articles. We can run a clustering algorithm on news articles given as an input to the algorithm and see what groups the different news articles fall into. The different clusters may be related to sports, politics, entertainment, climate, etc. Here again, the groups can be identified only after clustering is done, and we have no a priori knowledge of what the categories are since our data is not labeled. Based on whether the data are labeled or not, we can categorize machine learning algorithms into two main categories: supervised and unsupervised. Regression and classification are examples of supervised learning, in which the training data is labeled. In the examples discussed, for regression, the response variable or the label is the score obtained by each student in the predictive analytics course, which is a continuous numeric value. In the case of classification, each data point or observation is an email which is labeled as spam or ham, which basically is a categorical variable. Clustering, on the other hand, is an unsupervised method that has no labeled training data, and we merely utilize the unlabeled data to come up with groups or categories that can eventually be analyzed and interpreted. This is the difference between supervised methods and unsupervised methods. Why do we need training data and testing data? We are attempting to make predictions which can be done by using a model. To build this model, we need to use labeled data, also referred to as training data. Essentially, we build the model using training data, and then we can test how well a model does by checking its performance on new unseen data, also referred to as the test data. In the example considered for regression, we built a model using training data to forecast the score in the predictive analytics course for a student. We then test this model using test data to check how well the model does on unseen data. Similarly, for classification, we built a model to predict whether an email is ham or spam using labeled emails as training data. We can then check how well this model does by making predictions using this model on unseen test data. Let's look at a concrete example. Assume that you have about 10,000 emails with the label spam or ham. We need to train a model using the training data set, and then check this model's performance on the unseen test data set. So, you have 10,000 emails and you divide these emails into training and test data set such that there are 8,000 emails in the training data set and 2,000 emails in the testing data set. You basically use the 8,000 emails to build the model and the remaining 2,000 emails to test it. As you can notice, there are two distinct steps here. In the first step, we develop a model using the training data. In the next step, we use the built model to forecast if a new test data, such as a new email that we get, is correctly classified as spam or ham. Similarly, for regression, where we want to predict the score of a student in a predictive analytics course using their 10th grade scores as an input, we build a model using training data having the 10th grade math scores and corresponding predictive scores for each student. Then we use this built model to predict the predictive analytics scores for new students given only their math scores. So we basically build a model using training data and check how well this model is performing using the test data.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by upGrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course.